Okay, today's lesson, we just did an activity where you had to match graphs, tables, and equations, and a lot of you, the hardest part was finding which equation went with which table or which graph. So today we're actually going to be talking more about graphs, equations, and tables, but specifically number 2 says we're going to write an equation for a table, and then we'll use the equation to make predictions. So once you learn how to write an equation for a table, it also makes it easier to match equations to tables. We also have some other miscellaneous things in here. We're going to talk about geometric relationships, defining what a function is and a linear function, because this unit is all about functions and patterns, so it'll be helpful to know what a function is. And then we'll talk about how to identify functions. We'll be doing more with functions, so the big goal for today is writing the equations for the tables. Okay, this comes right out of your textbook. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So I'm going to start by making a table just like we did in the problem with the houses and the windows. So on this side of my table, I'm going to write the number of rectangles. And then on this side, this will be my dependent variable. I'm going to write the perimeter of the rectangle. Okay, so in the first scenario, I have one rectangle. What is the perimeter of this rectangle? Perimeter, recall, being the distance around the rectangle. We have the long side is 6 units. The short side is 1. Volunteer to tell me what the perimeter would be. Sophia? 14. Good. So the perimeter would be 14. If we have 2 rectangles, what is the perimeter now? Gretchen? No? Careful. A lot of people say 28 because you think it's going to be twice with one rectangle, but these sides are touching, so we're not counting those sides. Gabby? 16. Okay, if there are 3 rectangles, what's the perimeter? Gretchen, give this one a try. 18. Good. Okay, and the last one we have displayed up there are 4 rectangles. If we have 4 rectangles, what's the perimeter? Emma? 20. Okay, so I think you can probably see the pattern. Who could just describe in words to me the pattern that's going on here? Athena?
They're adding 2
it's adding 2 every time. So if we look at the column with perimeter, it's increasing by 2 every time. But the question becomes, how do we express that in an equation? And this is where it can be tricky sometimes because we're talking about a 2-step equation. Gretchen? Yes. Okay, so in order to put 2-step equation kinds of patterns to actually write the equation, I have kind of an easy way to do it. First, you look at where we are now. So right now, our perimeter is 20. If we were to go one more step, if we were to have 5 rectangles, what would the perimeter be? So you figured out the pattern by now. You know we're increasing by 2. So what would my next number be, my next perimeter? Kat?
22.
It would be 22. The difference is 2. We're going up by 2 every time, so I'm going to write for the change, positive 2. And then the next thing on my little chart here is start. Now it's not possible for there to be 0 rectangles, but if we were to keep going backwards, say we weren't talking about rectangles and this was just some random pattern, if we were to go back to the number 0 as our independent variable, what would the dependent variable be? Liz? No? Emma? No? Let's kind of stick a 0 down here. If we had a 0 here, what would we get out for our dependent variable? Let's look at what's happening as we go 4, 3, 2, 1. We're going 20, 18, 16, 14. Let me actually just stick the 0 in up here instead. So if we're going up, we're going in which direction? What are we doing? We're subtracting 2. So what would this be? 12. Good.
But if you don't have it, how do you still have that? Like if you don't have the rectangle at all, how do you have numbers?
Well, technically with rectangles, we can't have 0 rectangles. But I'll show you how this works as far as figuring out how to write the equation. Let me just erase this little random 0 down here. I'm not going to use that. Okay, so our start is what would happen if the independent variable was 0. Our start is 20. Now to figure out an equation that represents this pattern, it's really easy. We always have y equals whatever the change is times x. So our change was 2. So we have 2x plus whatever our starting value was. And they're always going to work out that way if they are a linear function, which we'll talk about linear functions in a little bit. Let me make my graph. My graph is rectangles. Number of rectangles is my independent variable. My dependent variable is the perimeter. I'm going to number this by 1, so I have 1, 2, 3, 4, 5, 6, let's go up to 7. And then since we're not starting until 12, I can't just start at 12 and go up by 1s or 2s. I can't leave a gap in my graph, otherwise it won't be accurate. So I'm going to go up by 4s. I'm going to go 4, 8, 12, 16, 20, 22, maybe go up one more, is 24. Okay, so if I were to graph the points that we had, my first order pair would be 1, 14. So that's going to be about here. And then I have 2, 16, 3, 18, 4, 20. And I could keep going. If I had 5, I would have, whoops, I numbered this wrong. It should be 24 and 28. Okay, so my next one would be 22, my next one's going to be 24, next one's going to be 26, and so on. If I were to draw a line through here, which I'm not going to do because I can't have half of a rectangle, I can only have whole rectangles, but if I were to draw a line, I'm going to end up crossing right at 12. That's what the start means. It means where does the graph start? If it doesn't cut through 0, 0 down here, if it doesn't cut through there, where does it start? It starts at, wait a second, something's wrong with my, no, I wrote the wrong thing here. Nobody caught this. Our start was not 20, it was 12. Gosh. Okay, 12, so it should be 2x plus 12. Sorry about that. Now that I've totally confused you. So you can see that from our graph. That's where it starts. It doesn't start at 0, 0, it starts at 12. And that's how you figure that out, is by going backwards. Hello. Okay, any questions other than that?
How do you know when to draw the line?
If it's something like, say, the growth of hair, okay? Your hair can grow in fractions of inches. It grows continuously. But when we're talking about data like rectangles, it's just 1 or it's 2. It can only be whole numbers. You can't represent the numbers in between. That's how you know. Good question. Okay, let's try this one. This is probably the last thing that we're going to do today, and then we'll pick up here again tomorrow. So I want you guys to try doing what we did, and then we'll talk about this one before the end of class. So I'll give you about 2 minutes to look at it, and then we'll talk about it. On this. Okay, so let's talk through this. We'll go kind of quickly since we're almost out of time. The table, I would put the number of triangles and then their perimeter. Okay, so if we have one triangle, we had a perimeter of 10. 2 triangles was a perimeter of 14. 3 triangles was a perimeter of 18. And 4 triangles was a perimeter of 22. So right now, we have a perimeter of 22. If we were to keep going, we're going to have a perimeter of 26 because it's changing by +4 every time. If we could go backwards and we could have 0 triangles, we would have a perimeter of 6. Even though that's not possible, that shows us where our graph is going to start. So our start value is 4. So we have y equals 4x plus 6. And I saw so many people who had the equation. How many of you had that equation correct? Okay, excellent, good. I am not going to give you any homework on this tonight. We will resume here tomorrow.